I'm Paul Hopewell. Welcome back to my workshop. In this video I'm showing you how I fixed a few issues with my Alba 1A shaper. These issues are all minor issues except for one which does concern me. It's a rattling sound that emanates from deep within. Try as I might, I can't create that random clunk that sounds like something just broke. Needless to say, when it does clonk, I've found that I can throw the clutch lever off faster than sound travels around my workshop. The click-clack sound, the noise you hear right now, I believe it's the rocker arm shifting over the bottom pivot pin. I think the only way to sort this problem is to take bits off the machine. Usually I would consult a handbook before taking anything apart in case I forget something during reassembly. After all, there's nothing worse than assembling everything to find you've still got a bucket full of bits and bobs left. Because I haven't got the aforementioned handbook, I've got a feeling that a bits bucket is going to be part of my toolkit. Also, one of my big worries is there's one of two types of springs that I know is lurking in there, and it is going to get me. One type is the type of spring that leaps out of an impossible to reach crevice and usually hides in the only place I could never ever get to again. Or it'll launch a steel ball across the full length of the workshop. The other type of spring is the one that quietly sits waiting for you to undo the very last thread on the last bolt before dumping an entirely disassembled gearbox in your lap. That isn't to say I haven't trolled various YouTube videos or the internet for clues, but that can only be used as a sort of guide. I also understand there isn't a maintenance manual for this machine. After finally managing to release the pointer from the square pin, I concentrated on removing various nuts, bolts, screws and pins and put them in the ne'er to be used again bucket. It's not my intention to show you how to strip an Alba shaper. I'm simply exploring it with the intention of putting right what I believe needs attention. And it's only guesswork without a handbook. The Gib strip that I've just removed shows all the signs of having been recently scraped. It saves me a job anyway. After removing the top pivot block slider and the ram body, I should in theory be able to just lift the rocker arm straight out. No surprises here then. The first clue is at the top of the rocker arm. It's been repaired using a couple of pieces of steel. And on further inspection, the main rocker arm also appears to have been replaced with a 1-inch thick steel one. Because everything inside this machine is as black as soot and just as messy, I might add, I couldn't see why it just simply wouldn't lift out. So in frustration I took the pivot bracket off instead, knowing that the entire machine will have to be disassembled. I've found an oiler point here. It was only accessible from the back, and I can't see any reason why, when I reassemble it, that it can't be the other way round. That is the oiler hole facing forwards. Before going too far, I rechecked the top slide to see if it was still level. It has moved a tiny bit, but I'm not going to alter anything since it's good enough. However, the table shows a different story, and I'm going to have to make sure it's true when I reassemble everything. You'll have to see the video Shaper Fix a Rushed Job that I published in May 2021, because the entire table assembly has been replaced and a larger indexing gear was made and fitted. Here we are once more, having to remove this heavy chunk. Mind you, it was a piece of cake to remove this time. After removing the rear ram guard, 3 of the bolts that held the shaper main body to the base are a straightforward loosen and finger spun out. But the one under the large clutch pulley is not so easy. I suppose I should have removed the clutch pulley first. We live and learn. This lump of wood was my only option for rolling the main body over so that I could see what was going on below. Well, I seem to have found in one foul swoop what the root of all the noise is and why the machine randomly clunked. The pinch bolt is missing. The rocker arm has not only been replaced, but it's been modified by a machine engineer who knows what he's doing. Too bad the person that rebuilt the machine only had a hammer and a screwdriver for a toolkit. A nicely made sliding bush was loosely held in place by a couple of electrician's brass nuts, ill-fitting ones at that, meaning that the nicely engineered pivoting slider was able to slop around from side to side, momentarily trapping or rubbing on whatever got in the way. After removing the bottom pivot and the slider, the rocker came out without a fuss. The bottom fork on the rocker arm has been modified to be wider, and the lower end of what was originally an open slot has now been bridged for strength. You can see here the pivot slide block and the two off-rings that were used as bushes. They fit on the lower pivot pin that is a very firm fit inside the main body. After wiping some of the muck off, evidence of past life wear has taken its toll where the lower part of the original rocker arm rubbed against it. Also, because there are 4 marks around this pin, it has been rotated once to provide a less worn face to the lower part of the rocker arm. Then, because I believe the old rocker arm suffered a catastrophic failure, a new rocker arm sporting a modified sliding bush was made to snugly fit over the bottom pivot pin and slide to and fro inside the lower part of the rocker arm, and because of its design should keep wear at this point down to a minimum. It's also got its own oiler well on the top. I'm taking the gearbox apart, all 2 speeds of it, just to see if there are any further issues or springs lurking around. Waggling the clutch lever didn't reveal anything, so I shoved the gear selector back and forth a few times to see if there was anything waiting to jump out at me. And there was. The gear selector fork has been secured in the wrong position on the selector rod. You can see here that the selector rod is rubbing against the back of the clutch pulley when the lower speed is selected. You can understand why I'm a little apprehensive about strong and unfamiliar springs because, well, they're vindictive devices. I unwound this bolt fully expecting that the last person to have fitted it used a short bolt and used something to preload the spring. As look at it, it was fine. Removing the through retaining bolt, the clutch cone came away, revealing a couple of very clean mating surfaces. When I say clean, I mean without any signs of wear. Things are looking up. After removing a large circlip, the clutch pulley slid off without too much fuss. This is the hidden end of the gear selector rod. Although it shows signs of contact wear, no damage has been caused to it or the inside of the clutch pulley beyond a few marks. These covers took very little effort to get them apart, as did the gears, and as there wasn't anything amiss to report, I put everything out of the way, then spent hours and hours cleaning and wire brushing and generally getting rid of all of the unwanted paint. I can't believe how much muck such a little machine can contain. Everything that was exposed to the grime flung from these parts, including me, looked like it had been sprayed black in a spray booth. Talking of painting, I hadn't planned to paint the Shaper for 2 reasons. 1, I'm not very good at painting, and 2, I'm not very good at painting. But my wife is, and although I robbed an electric motor out of her sewing machine a year or so ago, she was still happy to waft some red, green and yellow Smooth-Right paint all over the now semi-naked components. While the paintwork dried, I got on with the task of making stuff. In this particular case, the replacement of the two bottom pivot bushes that support and hold the brass pivot slider in place. I don't see the point in using brass or bronze for these bushes because they do nothing more than stop the bottom sliding pivot bush from drifting from side to side, so I've used aluminium or aluminum. They were machined to allow no more than 0.5 millimetre, that's 20th thou, free movement along the bottom pivot pin. This should stop some of the noise, and because the movement at this end is so small, I could probably have used nylon or even tufnel. When I bored out these bushes, I bored them to be 0.25 millimetre big, that's about 10th thou, because I knew that fitting them onto the bottom pivot pin during reassembly could prove problematic if they were a really good fit. After gauging the length of each part, I zeroed the saddle index marker to ensure that I returned to the same position after swapping tools. When I parted them off, I made one 25mm long and the other 19. That's 1 inch and 3/4 of an inch. I also chamfered them on both sides of the parting off slot before completely severing the part from the workpiece. While cleaning the shaper, I have found that there are 17 oil holes on this machine, including the extra one in the top of the bottom pivot slider. And every one needs to be oiled on a daily basis. Some places need oiling more than others. For this, I used an idea posted by Rustinox in December 2018, using brass to make oil reservoirs. I think the heading was "Making Simple Brass Oilers." However, I used household pipe and compression fittings along with a few spare bits of brass cut-off. Because it was simpler to make the parts and with a little bit of soldering easy to seal the fitted parts together. One of these oilers was sideways on that needed a similar fastening to the other oilers, but the press fit dowel was soldered to the side of the little reservoir. The dust caps for these oilers were made from some old brass stop ends from my now dwindling box of brass stuff. I held these stop ends by the hex nut and machined the threads off first. Then, after turning them round in the chuck, faced off and removed the hex from the OD to the same index mark on the cross slide. All 7 of these oilers are complete apart from a bit of polishing. They'll be hammered into place later. When I initially took the main body off the pedestal, Gravity was both my friend and my enemy because the body ended up on the mobile platform okay, but it was like a controlled crash dragging me along for the ride. I seem to forget that it was years ago that I would throw heavier billets of steel about like tennis balls. To put the main body back onto the pedestal as well as reassemble the various components, I needed a crane. And to get that I had to move my collection of motorcycles out of the garage, enabling me to get my engine crane. Dragging the crane around the garden is no easy job, but lifting the body back onto the pedestal without it would have been for me impossible. This is where the gear selector fork should be, but the selector fork clamping bolt has left a mark on the push rod proving it was in the wrong place. This is why the end of the push rod was touching the clutch pulley. Correcting this will also correct the gear alignment when the interlocks engage in the correct position. The original gear selector knob is busted. I replaced it with an identical one to the clutch lever. The gears seem to work okay. This is the end of the gearbox lay shaft. When I took it apart, like the bottom pivot pin, it too wasn't secure. With the aid of a long reach extension, I made sure that it was secure this time. The problem with this pinch bolt is that it's located partially inside a recess. Fortunately, the old socket I used still, but only just, managed to grip it. When I took it apart, there weren't any gaskets or seals on either side of this gearbox, and there aren't any now. I'm pretty sure it doesn't need any. So I screw the covers firmly into place. Refitting the rocker arm next. I've fitted the pivot bracket on the top, but I've made sure that the oiling point is facing forward and hopefully in view when everything is finished. Originally, the old system used to have the rocker arm that slotted over the pivot pin with a slip fit. Over time this would become less so and the rocker arm and pin would eventually start to knock more and more. To reduce this knock, maintenance crews would simply rotate the pin 90 degrees or so to reduce the amount of play until the noise became once again excessive. This machine has had a steel rocker arm made that has been engineered to reduce a lot of these issues by making a slider block that is a push fit over the pin and a sliding fit in the bottom of the rocker arm. The 4 wear patches on the pin are now acting as oil ways. Earlier on, this slider block was supposed to have been held in position by what I believe was an old electrical cable gland. This will now be replaced by a pair of aluminium or aluminum purpose-made sleeves. These sleeves will prevent the slider block from moving out of a stable position. The maximum amount of end float play is about 0.5 mm, 20 thou or so. Any less and it could be difficult to assemble the bottom pin, sleeve and the slider assembly while trying to support the rocker arm. Needless to say, it was still a bit awkward as it was. The missing pinch bolt was replaced and I made sure it wouldn't come out. The bull gear has also had its fair share of damage in the past, but as before, it appears to have been repaired to a very good standard. The top slider was a bit of a fiddly widget to get located in the bull gear slot. Despite what you see here, it did take quite some time to get all the components in place before nipping up the lock nut. This is the clutch push rod. It is only being used when the clutch is in the open position. Now it's time to remount the main body onto the pedestal using the 4 bolts. This time I'll put the bolts in place while the clutch pulley is still on the floor. That was a bit easier. With the engine crane out of the way, getting around should be a little bit less restrictive. Hanging both doors is a simple process, even if the hinges had been painted. When I finally found the missing steel ball and the spring, I put it back where it belongs, under compression on the gear change pushrod. Then I concentrated on reassembling the clutch pulley and the clutch cone. The cone is held in place with a pin that also acts as a clutch thrust bearing by being the go-between the clutch cone and the clutch pushrod. The clutch thrust spring, retaining washer and bolt completed the clutch assembly. It was then a simple job of winding the V-belt over the pulleys. I might add that this belt is surprisingly stretchy, but it doesn't stretch too far. The clutch lever is the next thing to go back on. I shortened this lever from its original length because it had been extended to such an unbelievable length as to reach over the table. I presume to assist the operator to sit in front of the machine instead of to the side. The lever action was a simple matter of screw the adjusting screw in or out to get the best operating position before locking it off. This is the lower part of the hinge for the bull wheel access door. I've altered the top of this door to allow me to take it off without having to remove this lower part of the hinge. In future it'll be easier to unlock and lock the bull wheel slide without the door being in the way. The pulley cover slides on in much the same manner, but has the habit of swinging open when the machine's working. To replace the slotted feed wheel, I need to be sure that I have put the pin in the right way round. Putting the pin in both sides of the drive shaft clearly showed which way the pin really needed to be. The same goes for the feed wheel. With the pin in place, there was rotationally excess play, caused by the tapered hole in the end shaft. I had a suitable tapered reamer to clean everything up, but I haven't got any spare tapered pins at the moment, so I need to be careful. Careful as not to open the tapered hole any further than is absolutely necessary. I don't want to repair the hole and not be able to use the pin until I get a replacement. I used an old pop rivet as a drift to drive the pin home. It did the job. The old pin now sticks out of the bottom much further, but not quite enough so as not to bridge both sides of each joint face. That'll do. Now it's time to put the ram body back into its rightful place. So after a good wiping down and a good dousing in slide oil, it was unceremoniously plonked back on. The pivot bracket found its way clear to poke out of the top as if in anticipation of meeting up with its old buddies, washer, big nut and pointer. So I didn't disappoint it. The next job was to calibrate the pointer to the indicator that's riveted to the top of the main body. I simply set the bull wheel to its largest setting and manually rotated the clutch. By placing a 12-inch rule next to the pointer on the top, I measured the sweep and kept resetting and re-sweeping until I achieved a full 10-inch stroke. Then it was a case of bend the pointer over the 10-inch mark on the indicator strip. The ram packing strip was next, but not before I'd removed the little ball oilers. Most of the time the oil can couldn't get any oil into them. I don't think they were a bad thing. I just didn't like them. Replacing the bolts and the adjusting screws, I devised a plan for resetting them. My plan was to tighten the bolts quite firmly and see what happened to the ram. If the ram still moved quite freely, like it did, then starting with the middle adjuster, I screwed it in, with considerable effort I might add, until the ram received a modicum of friction. Then I locked it off and checked the adjacent bolt was still tight. I repeated this operation twice more with the other bolts and adjusters, each time receiving more resistance to my pushing the ram. It may have been a bit on the firm side, but after a further dousing of slide oil on the ram, it began to ease when the motor got a hold of it. The rear ram guard went back on using the proper screws. These homemade oil pots are just the ticket, but I still had to modify the front two because they were too tall. To get the old oilers out of the main body, I used 2 wood screws and a crowbar because I couldn't find my claw hammer. The new oil pots fitted a treat, with just the right amount of pressure to ensure they stayed put. It's a good thing really that the 2 front oil pots are smaller, because anything longer than an 8-inch slide cut would allow these front pots to drain into fresh air. I ran it for a few moments just to let oil run through. It seems to be working quite nicely. The toolbox slide assembly has to be inverted in order to release or refit the cam lock. This was a particular nuisance when I disassembled it, because not having a maintenance manual and not knowing how to remove this cam lock provided me with hours of entertainment. On reassembly, the cam lock was less than effective at locking the tool slide assembly until I removed a burr off the cam face. The square tapped bolt, pin or locking screw didn't seem right somehow. Still, this is where it came from, so this is where it went back. The Gib strip on the toolbox slide assembly was the next to be given attention, and again I started with a centre setting screw, by first nipping it up until I could feel a little frictional resistance, and then continued to do the same with the other screws. A DTI gauge will be used when the machine is cutting to see if there's any undue play before increasing the tension. While the toolbox slide assembly was being cleaned, I took the time to drill and tap through, enabling me to fit a locking screw. And as luck would have it, I found one on my wife's old sewing machine. The swivel base is held in place by 1 screw and a bolt. The pivot screw, when tight, barely allows any rotational movement, and like the locking nut, it has to be freed off to make any rotational adjustments. The swing base and the swivel base are almost always referred to as the clapper box. On this machine, everything on the clapper box is a very nice fit. Even the nip screw has a nice feel about it. The 3 remaining oil pots are fitted next. The first lubricates the bull gear pivot, the second lubricates the gearbox, and the third keeps the clutch mechanism in good order. Both the bull gear and the gearbox pots will be regularly topped up. The clutch oiler will receive a once daily shot. I've still got to drizzle oil in 10 other places and grease the transfer gears daily though. To stop the pulley cover from opening at will, I'm going to use an altered spring clip supported by the cover's handle to pass through an opening in the casting. That should do the trick. The bull gear access cover is much better now. I can remove it to aid access. I'll swap the square bolt out for a better and more acceptable size screw. I'll use the square bolt, I think, to prevent the cam from coming loose. I had to take the table assembly apart again to get it painted, but this gave me the opportunity to fix the droop shown at the beginning of this video. One thing I did that I didn't show on the video was that I fitted shims behind these keep strips. These keep strips don't lie flat when the bolts are tight, so they act more like clamps than slides. Placing shims along the bolt line allowed them to be fully tightened, providing a low level of drag. I used greaseproof paper for this, 3 layers at first. Later, when I made final adjustments to these keep plates, 1 layer of greaseproof paper was enough to provide a high level of drag. But at least I no longer have to slack off the keep plates to do a course height adjustment. There are only 2 Gib Strip adjusters here. I nipped them up for a moment or two while I reseated the table rising screw. The riser screw sits in this pocket and a pinch bolt prevents it from going anywhere. As before, I nipped up the Gib screws to a level that produced a little friction each, knowing that this process will have to be done again a little later. Because I've overpacked the keep plates for now, the table looks a bit unsteady when I wind it up, but it does improve. I've found that the cross slide table has to be placed on the main cross slide in a particular order. The table cross slide simply hooks on. The cross slide nut can now be pushed into place and it's not easy to do. The table slide I've found won't hook onto the cross slide with the nut in place. Now the screw can be wound in most of the way. The screw holds the nut at the right orientation for the next operation. For this I use a small G-clamp to press the nut home in its pocketed location. If you don't, it will probably bend the cross slide screw. From here on, everything else is straightforward. This hand crank has got to go. At this stage, all the various Gib and keep strips were added to partially take up any slack in the cross slide. The cross slide and the main vertical slide both received a dousing of oil and a good workout before the final setting and tensioning could take place. However, the screws in the back of this cross slide have to be almost all the way home to prevent them getting damaged across the back of the main cross slide body. Because there's not a lot of room at the back for the screws to pass through. Even the lock nuts are very thin. Throughout most of my working life, the machines I used were working 24/7 and the maintenance teams were very busy chaps, often working with the instructions to get that machine running again quickly. We, the machine operators, had to use all our skills and knowledge of the machine we were using to make perfect products every time, on machines that were many times well past their sell-by date. What I'm saying is that the machine you're using will probably not be perfect, but your knowledge of the machine and its limitations can help you overcome some very challenging hurdles. Up to this point, all the table slides have been loosely assembled. It's now time to make the final adjustments to all the slides. That means removing unnecessary shimming from under the keep plates and setting the gib strips. For the most part, I prefer to set the gib strips by feel. For instance, with the locking nut out of the way and a free running screw, you can feel when the screw has pressed the gib strip onto the oil. A little more and you can feel when the gib strip has pressed up against the slideway, and you can definitely tell when the gib strip isn't going any further. Combined with this, operating the slide control, which is usually a hand wheel, you can feel the difference between the gib strip sliding on the oil, sliding on the slideway, or being trapped. If the gib strip is bent, the feel between touching the slide and stopping the slide is hard to read or feel, and therefore needs to be repaired or replaced. If the slideway is worn, it too needs to be repaired. That, of course, is in a perfect world. I can imagine that most hobby shop machines are second-hand or budget machines like mine. I would suspect also that not many are perfectly accurate. What I would say to all you hobby machinists out there is whatever machines you buy, make sure you get the best measuring devices you can afford. This will go a long way to helping you achieve your goal. After my little digression, the table is on and the slideways are set and oiled. With that, I connected the Traverse operating rod, set the machine going and gave everything the good once over. Let's see if anything fell off. Well, it sounds much better, and I nearly made the mistake of leaving the hand crank on when the feed was engaged. That wouldn't have ended well. Now that I've reset the slideways, the table is now back in line parallel to the ram. It's not perfect, but I'm happy with that. Don't forget to subscribe and click the like button if you've enjoyed what you've seen. Also, if you have any comments, please feel free to leave them in the comments section. Once again, thanks for watching. Bye for now.